Very good morning. So, in this particular lecture of Geomagic Design X Go, we are going to learn on the points processing tools. So, in Geomagic Design X Go, we have ample capabilities to work with point cloud data. We have got abilities to align the point clouds data and convert those point cloud data into meshes. This process is called triangulation, so we also support triangulating a point cloud file to form meshes. So here we can go ahead into our lesson. So we can go ahead and import our point cloud. So in the import menu, as you can see my screen, click on import, and in day 2 we will have a particular folder called E1. So in day 2, we have all these particular point cloud files provided. So we have 6 different point clouds. So you can click and select shift on the last point cloud and import all of them together. So here there are a few different options. So if you want to import the point cloud data along with the vertex and normal, you can include this check mark. If you don't need this, you can uncheck it. For now, please leave it on including vertex normal. And here in the sampling ratio, we have a few different ratios. So these are smaller point clouds, so we can choose 1:1 where we import the entire point cloud. But in cases where you have larger point clouds, say for example, the point cloud of room which is scanned, or something which is scanned in a very small resolution so that you have an enormous number of points, if needed, you can choose 1/4, 1/9, 1/16, depending on how big the point cloud is. This would import a fourth of the point cloud. The second 1/9 would import a ninth of the point cloud, a 16th of the point cloud, and so on. So, if the point cloud size is very large, you can choose to reduce the number of points this way. But for now, let's go ahead with 1:1 and say import only. Now, we can see that this particular import has imported a few different point clouds, and we don't see them explicitly on the top portion of the model tree shown here. But in the bottom portion of the model tree, there's an object called point clouds. You see where my cursor is? And you can expand them, and you can see that you have all the point clouds scan 3, 4, 5, 6, 1, 2. Basically, scans 1 to 6 as point clouds are imported, and each of them have a different color. So if you take your scroll wheel and if you zoom in, you'll see that they're not surfaces like they were in the previous case, but they're rather point clouds. So if you zoom in, you'll be able to see that it's a collection of points out there. Then you can also see that there are some points that are outside the system of this main domain. So you can hide your reference planes for now. And you can see that there are 6 different point clouds. So you can hide all of them by clicking on the toggle, as you can see here. And you can see and explore them one by one. So this is scan 3. So the body was scanned from angle 1 and it gave us scan 3. Then you have scan 4. It's very possible that some bodies are not scannable with a single pass. So there would be cases where you would have to scan them in multiple passes. And here you have scan 5, scan 6, scan 1, and scan 2. Now, we have all these different point clouds, and we can right away see that these point clouds are not aligned with respect to each other. So in the top, you'll see that there's a points tab. So here you have the features that are needed to work with the point cloud data. But in order to work with them, we need to perform an alignment process first. So you can go here to the alignment tab, and there's an option called align between scan data. So in lesson 2, we kind of saw how we can align and a scan to its part coordinate system by making use of the features present in this particular scan, like flat faces, cylinders, axes, etc. But this is another case where we are aligning different angles of the scan data with itself. So align between scan data tool has to be used then. It's the tool that I have on my screen right now. It's used to align the meshes or point clouds. You can also align meshes this way and stitch them up together. So click on align between scan data. Now you'll see that there are 3 different options: local based on auto guess, local based on auto on picked point, and global and find. Now the first method, local based on auto guess, will recognize the point clouds. It will identify for areas with similar curvature variations, and it will automatically attempt to stitch the points that way. And in the second method, we have local based on pick point. So we can click on local based on pick point. We're gonna basically pick common points within these scans and ensure that they're gonna align up together. So for the purpose of this, there would be 2 boxes. One is a reference scan and a moving scan. And you can see that the screen has split into 2. So you can identify for scans that have similar areas within it together. Say, for example, this red scan and this blue scan, which is scan 3 and scan 1. So I'm going to start by hiding everything other than scan 3 and scan 1. So we have these 2 different objects here, and if we look in the model tree, we can see scan 1 and likewise scan 3. And we can choose scan 1 as a reference. So here, click on reference. When you click on reference, it will have a yellow border highlighting it outside of it. So you can pick scan 1 as a reference, and for the moving, we're going to pick scan 3. Now you can see that this is a pretty good data. So you have matching areas between these scans. Now scan 3 has some areas that scan 1 does not have, and since scan 1 is the reference, it will not move while you are making your alignment. So the process to perform alignment is very simple. We need to pick 3 areas of the scan, and the software will automatically align them accordingly. You don't need to be very accurate, you just need to be close enough. So here I have oriented both of these areas to look similar, and as you can see, they are in their initial configuration here, but now I'm going to pick this area here. And you can see that a point in red came out. Now I'm going to pick a similar area here. Then you can see that the software attempted to align both of them with a single point. Now I'm going to add another point here on this side, and it shows this as a green ball, and I'm doing point 2, a matching point on the movie. So it's also important to note that you need a minimum of 3 points, and it's preferable if those 3 points are not on a single plane. So I'll take 1 point along this cylindrical area, and I'm gonna try to take a matching point there. Now on the left hand side, you can see that the software has used these 3 points, and it has moved the moving data, the blue scan, to match with these 3 points. Now you can stop here, but You can also use further points if needed. Say, for example, if you want to take a fourth point, you could go to this area and pick points out there. The more the number of points you have, uh, the better fitting the output is going to look like. Now here we have scan data in the reference, but we don't have scan data in the moving, so we cannot utilize an area like this. Now we can rotate further, and you can see that you have scan data here, but you don't have any scan data in the moving. So those type of areas cannot be chosen. But you could kind of align the part this way. And if you find that there's like a particular area where you do have scan data, like this area, you can pick them up together. So any number of points can be selected. It's recommended to select 8 points, but at a minimum, you need at least 3 points. So in this particular case, we have selected 1, 2, 3, 4, and 5 different points. And on the left hand side, the preview looks pretty good. As you can see, the part has come along. It's sort of like an initial type of an alignment where the moving scan is brought very close to the reference scan. Now we have another option here called refine alignment. You can choose to check it on or you can check it off. So if you check it on, after this particular alignment has been performed, the software will align it further. So I'm going to hit the check mark here near where it says method, and you can see that the software has applied its algorithm and it has brought them even more closer. After this, you can say OK. So now we have scan 1 and scan 3 aligned with respect to each other. Now, I can either proceed forward with this alignment, or you can go into align between scan data again. So I'm going to make a click here. And this time we can choose to do a global and fine. So a global and fine type of an alignment is an alignment where you're going to apply small movements to the moving and the reference data. So if you keep a scan in the reference, it would not be moved. Say, for example, I can choose scan 1 as reference and scan 3 as moving. So I've selected them accordingly. And we have a set of options here. So sampling ratio is at auto, so you can choose it to be 100% as well, where it will try to move the moving data, which is scan 3 in this case, by small transformations. So you can apply small transformations. You can check that on. It would try to move it and iteratively reduce the maximum average deviation between the reference scan and the moving scan. So here we have given an iteration count of 20. You can increase it to say 40 if needed. And the max average deviation is selected by default with the auto. The software recognizes it. And here it is trying to bring that maximum average deviation to 0.0169. And the sampling ratio also, you can change it from 25 to say 50. And you can give a check mark. So when this particular process happens, the software resolves the alignment, it refines the alignment to make it further tight and ensure that you get a very good fit between the reference and the moving data. So here we can see that in the step 1, we used the pick point method to bring the reference and moving point clouds close to each other. Now we have used the global and fine to refine that alignment further. So here we have scan 1 and scan 3, and we can see that it's still 2 scans. So you can go and combine them in the points tab. So here we can go into the points tab, and there's an option called combine. So combine option would combine multiple point clouds or meshes to create a single point cloud. So you can go here on combine and make a click. So when you click on combine, there will be this widget that pops up which asks you for only one input. The only input asked is how many point clouds are there. So you can make a drag box and select these 2 point clouds. Now there's gonna be another box, a checkbox here in the bottom, which says, do you want to remove the overlapping regions or not? So overlapping regions associate for these type of areas where you have points in both the scan 1 and scan 3. So the red point cloud here has got points in that area, the blue point cloud has points in that area. So if you want to remove overlapping points, you can check this checkbox and say OK. So the software would now combine both of them to form a single point cloud. As you can see, we just have a single point cloud, and in our model tree, it would be renamed. So here we have a body called scan 1 and scan 3 in our model tree, where you see my cursor. And you can rename it to, let us say, something else. Let us say combined scan. Now, we are going to use this combined scan as our master and we as a reference, and we are going to align the further point clouds. So I've shown scan 4 here, and as you can see, they don't seem to be having a lot of, there is enough data that we can use to align them together. But let's go to the next one, scan 5. So here we see that both of them don't have any common areas. We have scan 6, where we do have some common areas that we can use to align. And we have scan 2. So at this stage, I can use scan 2. So we can go back to our alignment tab. We can go to align between scan data. So click on align between scan data, and we use the local based on pick point method. So choose the radio button on local based on pick point. Now the reference has to be the combined scan. Typically, the scan that has more data is used as a reference, and the one that has lesser data is used as moving. So now I click on moving and I click on scan 2. Now all we need to do is pick common points. So in order to do that, I'm trying to keep them in a similar looking orientation. You can also use this align to normal type of a view, and you can pick identical areas on both sides. And now you can go ahead and pick the points. So I'm gonna pick a point here. I'm gonna pick that matching point here. And if you make a mistake, say for example, I wanted to pick a point, let us say I wanna select this point here, and by accident in the moving data I selected this point for green. Then all you need to do is do a Control Z, that would undo that selection, and you can come over here and add your second point. So that's our second point, and you don't need to be very accurate or anything with respect to these particular areas. So if you feel like this is a rough center, you can click that, and you can click loosely that area there. So here on the left hand side, you can see that they're already kind of coupled up together. So you can move the screen as per your convenience, and you can see that they're almost there. You can either choose to add another point, say for example, something like this point here to this point there. And we have the refine alignment on check, and note that there are two checkboxes, so you have to click apply on the method checkbox, and then you have to apply another checkbox on top. And following this, we can do another global and fine alignment. So we go to global and fine. Reference would be the combined scan, and moving would be the scan 2. And you can just hit check mark with the default settings that you have, and once it's done, you can say okay. So you can also choose more points, like let us say 50 points. And also note that you can choose both of them under moving. So if you want, you can also choose multiple scans. You can also align without a reference. That is also possible, and the software would provide you the updated results like this. Now, the next process is to combine them. So again, we go to the Points tab, we click on the Points tab, we go to Combine, we select both of these point clouds, and we also have Remove Overlap checked on. So this process can be repeated for the further scans. So let's do it together. We go to the Alignment tab, Align between scan data, we choose Reference as the larger scan, then we choose Moving as the other scan, let us say scan 4. And let's show it here. We do have some data. So you can also try this local based on auto guess. So this is another method that is present. You have some dials like a preference for speed and quality, and you can keep these check for if features are sufficient in overlapped areas, and you can try giving a checkbox. This would give a close aligning result like this, and at this stage you can say okay, and then if needed you can do a global and fine alignment again, so you can choose both combined and scan in moving, and you can say apply this transformation. Now this would dial in this particular body as well. So the local and local based on auto guess is more like an automation where the software automatically identifies features present in the point cloud and would attempt to stick those two together. So now I can click on points again, and I'm going to do the combine process and say okay. It's good to practice this as there would be situations when you would have to do this particular process. So it's alignment tab, you go align between scan data. If you're using the auto guess, you can choose your reference, and for moving you can choose multiple scans. You can choose scan 5 and scan 6. So here in reference I have the larger scan, and you can try a local based on auto guess, and it usually would give you good results. And if it does not, you can always choose the local based on pick point method. So here we have this, and I can go ahead and do a global and fine again. So here I'll keep all of them under moving, and you can say okay. So now the software would move the transformations, it would apply the transformation to all three of these scans and ensure that they're aligned close and good. So here we have applied three of these scans and we have aligned them. The combined scan, scan 5 and scan 6. So we go into the points tab and we say combine, and we can also do Control A if you want to select all of them at once. Have remove overlap region on and say OK. So here, as you can see, the point clouds are combined to form one point cloud, and you can click on this point cloud's name and rename it as part_1, or whichever name feels fit. You can choose that particular option. Now that we have aligned this particular body, there are a few other things you can do. One is filter noise. So filter noise is used to automatically remove a group of points outside the domain of the point cloud. So you can choose the maximum polyvertex count per noise cluster. So if you say 100 points, and if a cluster has more than 100 points, it would remove that. It would try to like remove within 100 points. If there's like a noisy cluster, it would remove it. And here you can also choose an outlier region. If there are a lot of points that are outside a particular range, you can either make a box like this, and you can modify this bounding box as well. You can make it larger or smaller by clicking on these blue dots and playing with these arrows that are present here to put forward a condition, say like okay, we don't want any scan points outside this area to be included. And you can also hold a vertex, hold an edge like this, and rotate to match the area and bring these bring these cubes as close to as needed. So I can like bring close and use this as my filter outlier region. So anything within this box volume would be filtered out. And you also have another option for the scanner range, but I would prefer the box volume option. And you can also uncheck this as it's not mandatory. And you can say, okay, so the mesh would apply this particular filter noise and remove any noisy clusters. And if you zoom in, you'll also be able to notice that there are more points in some areas and lesser points in some areas. So you can make these point displacements a bit more uniform. You can improve the distribution of points by performing a resampling. Uh, this process is also helpful in reducing the total number of points in a point cloud. Like some point clouds would be very, very dense. So you can resample, or in other words, redistribute the distance between the points. So we have two formulation uniform ratio where you can say, hey, when I'm applying 100%, there's like 493,000 points here. Let us say I want to make this particular model with just 25%, which is a very less number, 123,455 points. And if you consider this, check this consider curvature box, it would ensure that you have more points in areas where there are variations in curvature, like in these bendings, filletings type areas where there's sudden change in direction. It would maintain points there. And you also have a uniform distance option where you can say provide a uniform distance between the points. Say you want the points to be spread at 0.1 millimeters distance of each. You want them to be at 0.2 millimeters distance. It would update accordingly. So you can choose whichever formulation works, and you can say okay, and you'll find that the points will be more uniformly distributed. This is how we can bring in a point cloud, align the point cloud, filter the noises in the point cloud. And even at this stage, you can perform reverse engineering by fitting planes here. You would not be able to use tools like Smart Selector. It will happen, but it's a bit more of an involved process. So you can select it here, and if you fit a plane, right? So you can best fit a plane, and you can definitely start reverse engineering from this stage itself, like that. So you can, if needed, you can start the reverse engineering process from this stage itself. As you can see, it gives you all the requisite sketches, but it's always better to use a mesh for reverse engineering. It's more comfortable that way. So in the points tab, if we go to the points tab, we do have an option called triangulate. So the triangle, so currently we have a point cloud, and a mesh is constructed by connecting the vertices present in the point cloud, and it will give you a mesh surface. So you can click on triangulate, and you'll see that since we have only one point cloud, it by default takes in this part one. But if it's not the case, you can also pick part one, and we have a few different methods for triangulation: 2D, 3D triangulation, followed by mesh construction and HD mesh construction. So you can use either mesh construction or HD mesh construction. So if I go to mesh construction, you would have some dials here where you can set a geometry capture accuracy. So this is basically how close you want it to fit to the initial point cloud. And you have a checkbox for removing original scan data. So after it makes the mesh, it would delete the point cloud. So you can keep it checked on if needed. And there is a noise filter here as well. So if you need it, you can check that reduce noise filter. And removing redundant points, you can keep it somewhere in the middle, or you can keep it to more. And here you have a preview button as well. So you can click on preview, and the software will make this particular mesh for you. And you can see that it has made this mesh, and you can see the vertices that it used to make that particular mesh. Now you can also use the HD mesh construction approach. So this is a different algorithm. It provides very nice and detailed outputs. It takes slightly a bit longer amount of time, and it needs the vertex normal informations to perform this HD mesh construction. So you can keep it at a good noise reduction level, and you can also choose to extend boundaries if the scan was open and need to be extended, and you can take a preview here. So this is the second commonly used approach called HD mesh construction. If the body or the scan is like an object or a machined part or something smaller, you can use HD mesh construction to get very good results like this. Then you can say okay. So we clicked on accept, and we can see that our first mesh object part 1 pops up here, and we have constructed our first mesh. Now you can go to the edges, and you can see all the polygons that or all the points that are connected together to form these mesh. And you can see that there is a very good quality mesh that is outputted over here. And you can apply some minor repairs. So say for example there's a hole here. So in order to fill a hole like that, you can go to the polygons tab where you see my cursor. It's right besides the points tab, and you can go to fill holes, and you can choose the boundary. So it asks you for boundaries. You can click on this boundary, and you can keep curvature nature of filling the hole. So I keep it at tangent, and you can take a preview, and you can say okay. So now that particular hole present in the mesh has been filled, and you can also apply this any number of times. So I'm making a drag box across the whole model, and if there are any holes you don't want to fill, you can hold control and click. So I don't want to fill these two holes, so I can hold control click and finish out my holes. So this is how we can go from point cloud to a complete mesh. And if there are any artifacts, as you can see here, you can always select out that area and fill those holes. So I'm selecting out these particular areas, as you can see, and when they're selected they turn turquoise, and I can press a delete on my keyboard. Now we see that there are some extra artifacts here. So I can use a flood selection mode. So this selection mode will select all the connected polygons. So I can click and select all the connected polygons. Then I can remove the disconnected ones by right clicking and say inverse polyfaces. So when I click on that, the disconnected ones are selected, and we can press delete on our keyboard. Following this, you can fill out these holes as necessary and say OK. So this is a very nice and easy way in which we can convert point cloud files into meshes. This is particularly beneficial because we can extract mesh fit surfaces in Design X Go, and in the further versions of our software we can use several different wizards to extract lofted surfaces, to extract extruded surfaces, revolved surfaces, etc. Thank you.